Now let's talk about diagonal matrices. A diagonal matrix is also a square matrix, and in all of the off diagonals there are zeros. So as a simple example, let's have matrix L, and it will be a square diagonal matrix. 5, 7, 2 on the diagonals, and the off diagonals will all be zeros. So that's a diagonal matrix. Now, diagonalization can be done on any square matrix. So let's go to our matrix A, which is 3, 2, 7, 1, 4, 0, and 6, 2, 3 going across. And in order to diagonalize matrix A, you just zero out every non-diagonal element. So let's say D is the diagonalized form of matrix A. It will be 3, 4, 3 on the diagonals and zeros on the off diagonals. It's as simple as that. Now, diagonal matrices are used to weight rows or columns of other matrices. So pre-multiplying by the diagonal matrix weights the rows, and post-multiplying by the diagonal matrix will weight the columns. So for example, let's say we wish to double the elements in the first row of matrix A by 2, triple the second row, and on the third row we want to quadruple the elements. So let's have a W is the weights. So we want to double the first row, triple the second row, and quadruple the third row. So let's do that weight matrix times A. And the result will be 6, 4, 14, 3, 12, 0, 24, 8, and 12. Now if you look here, so remember we wanted to double the first row, in which we did. 2 times 3 is 6, 2 times 2 is 4, 2 times 7 is 14. We tripled the second row, 3, 12, and 0, and then we quadrupled the third row with 24, 8, and 12. Now let's see what happens when we do it the other way. A times W. Remember, like I said before, post-multiplying will weight the columns. So we're going to double the first column, triple the second column, and we'll quadruple the third column. Excuse me, that's a 2. So that's 28 there. So what we did, we have 2 times the first column, so 2 times 3 is 6, 2 times 1 is 2, and 2 times 6 is 12. We also tripled the second column and quadrupled the third column. So that's our A and W matrix. It probably tastes pretty good. So once again, pre-multiplying will give you weighted rows, and post-multiplying will give you weighted columns. And we'll actually talk about the use for diagonal matrices in the next video. But first, let's go to Excel and demonstrate how to do this here. Okay, I already entered your A here, and the diagonal matrix of A will just be the diagonals here with zeros everywhere else. W, in this case, we wanted to double, then triple, then quadruple with zeros everywhere else. Can't spell. So this is W first, and then A. Oops, I only did the first one there. Let's try it again. And then let's do A first, and then W to weight the columns. And let's compare that to what we had before. See if I can get it up. There we go. And it does look like it matched. So that's how you do diagonal matrices and weight columns and rows.